computer. All right, hello everyone. Happy Halloween, first of all. As you can see, I am dressed up by vote. The vote was 1-0 when I decided to dress up, so thank you, Chris. Today we're going to be covering forensics. So here is the flag, and the relevant meme is from Perfect Blues CTF. It's CTF categories arranged by creativity. Yeah, grep, clone, crypto, web, miss, and then forensics. So, and then the flag is keep off with your head, which is a pun on Kibana, which is just the worst software. So, give you all a minute to type that in, and then we will move on. What are everyone's Halloween costumes? Anybody got something fun? Okay, well, you can't go as yourself. We can't all just go as ourselves.
I'm thinking of doing Enderman, but I don't know where to go.
That's fun. That's fun.
Enderman will be fun. I will be the hash flinging slasher.
I want a box for that. I have to pay there. I don't have time. I probably do have to see
Good thing about clothing.
Pete, what's your Halloween costume?
Oh, yeah.
No, I need to get one from Wireshark.
Good stuff. If you need a Halloween costume, get one from Ragstock. They're good. Really?
It's like $50 for like a hot sauce.
No, that's ridiculous. It's not, just make one. My friend's going as Granger Bob. It's really funny. He printed. Chris, have you seen the photos? Oh, I'll have to have Bradley send you some photos. They're really good. Yeah. And she's going as like, yeah, literally. Do you know who this is?
I know.
It's literally the first bad guy from Naruto. It's as if like I wanted to go as a Mario character and I picked Goomba. So. Is it working?
It is not uploading.
Yeah, I don't. Yeah, so we may be at our upload limit for our instance of CTFD, which is running on half a gig of RAM on AWS right now. So we're fixing it next week, along with SIGPwny, which we have been saying we need to do for a while.
Crypto being guessed the paper is very accurate.
True. All right, real quick announcements, and then we're going to get to this stuff. There are 3 more open meeting spaces. That may have gone down to 2 for the rest of the semester. So we're going to be running like 31 meetings this semester, which is really, really cool. We've never run that many meetings before. And we've got 2 or 3 more. So if you're interested, if you have something that you're interested in running a meeting, please reach out to us. We have meeting ideas and we have meeting content to fill that, but we're intentionally leaving it open. So if someone's interested in running a meeting, you're more than welcome to. Okay, merch form, but for real this time. At 6 p.m. today, we're going to send out a merch interest form. So basically, like, would you buy a like a SIGPwny shirt or a SIGPwny jacket or a hat with the SIGPwny logo on it or a mug? Just, you know, we're going to send out like a big list of stuff. And if you're interested, then let us know. And then this Sunday, we're going to be doing some Halloween shenanigans. So the meeting title is called SIGPwny Summary. It's basically, it's basically just, hey, here's the cool stuff that we cover. Here's who we are. We're going to record it and you can send it to your parents if you are doing SIGPwny things. And they're like, what are you doing? And you say SIGPwny. It's like, that really didn't make sense to my parents for like 2 years. And by then I was an admin. So it took them a lot of explaining. So hopefully this video will just be like a 20-minute video that'll be like, here's all the stuff that we do. So let's move on to what we're doing today. So what is forensics? Forensics it's that 5th, why do I keep dropping things? Oh my God. It's that 5th category of CTF that is kind of guessy. It's about as guessy as crypto, but it's fun if it's done well. So forensics in a practical term is the analysis of computer systems information. Very importantly, it's different from OSINT because OSINT, generally the information is implied that it's public or semi-public. And then forensics is really often like after the fact versus OSINT, which is more often than not before the fact. And the fact is like an attack or a pen test or like some event. So there's a bunch of different types of forensics. I kind of just wrote 5 that are most common. Again, it's a really big field, just like everything in security. So there's file forensics, and we're going to be doing today. Steganography, which is like some of the most guessy stuff that exists. Like within like the guessiest category, it's the guessiest stuff. Then memory forensics, so RAM dumps, CPU dumps, like full disk dumps. So like memory forensics includes stuff like live and dead analysis, along with kind of like that kind of also falls under systems analysis. And then network forensics, so like looking at network packet captures and like just networks as a whole and what they were doing at certain times. And then lastly, we don't have any challenges for it, but we're going to super briefly cover systems and organization-based forensics, just because it's something that's important to know that exists, because there's billions of dollars in it. So yeah. So the basic forensic tools. We're going to start with some of the common command line tools and like some of the first things you should do when you're looking at like a file. I think I skipped a slide already. So the first thing I would recommend doing is just run the file command. And the file command will attempt to determine the type of a file, what it really is. How it does that is more often than not based on something called a file header. So a file header is a few bytes, usually like 3 or 4, right at the start of a file that dictates what type of file it is. So like, I don't remember. I think PNGs are like 7434 or something similar to that. And if you see those things at the start of a file, you can recognize, oh, okay, I know what this is. It is a docx file, or like, et cetera, et cetera, et cetera. So a big thing here is that you can rename files. Like if you report out a PNG file and you just called it file from like ImageMagick or something, there is a chance that it is, sorry, my aunt was calling me. Hi, I'm gonna just refer you to this video. So you could use like ImageMagick and you could output the file as like just a raw file instead of like a PNG. You rename it to a PNG and then it's a PNG. And how it opens and how it's processed really is wholly dependent on what the extension is. So if a file be opened in a different way, don't always trust the extension. That's pretty huge. Like a PNG could be a zip. A text file could be a PNG. It really depends. I'm gonna go a little bit faster. Strings. It just sees what strings exist in a file. It's really valuable when it's like a binary or a PNG, and there's a chance that there might be something hidden in this. You can combine it with grep to like search through those strings. Definitely do that. It can give useful information about stuff like functions, variables, any constants that exist. If it's a really bad reversing challenge, sometimes it's just in there and you can run strings on it. And then XXD, if you want to try and gather some of the like important patterns of a file, you can dump it into XXD and it'll give you a hex dump. Right here, so like right at the start. Wow, this is valuable. Right at the start of a file, that's usually where the header will be. And then sometimes at the end of a file, so like there's like that can usually be where the tail of it is. And that can often just mean like, oh, okay, here's the end of this file. Like I don't need, like, don't stop reading it. Which will dictate like the end of the PNG, and maybe after that there's like metadata or something, who knows. It's good to look for like recognizable hex patterns. So like you can filter by common like hex patterns or strings or something like that in here. And then grep. Grep is really the way to find things. Big way is to like run a file that or like run a command that'll produce something that std out, which is like your terminal string, and then grep for it. So like you can cat a file, which will print out the contents of the file, and then you can grep for like flag or SIGPwny or something like that. That's definitely something that's super valuable. Cool. Metadata. It's data, but meta. Oh boy, that word has more meaning now. So it's data, but meta. No, it is not Facebook's stupid name. Metadata is actually data that is about data. When something happens, basically, or like how big something is. How big something is can actually be really important. Because say you have a PNG that is like a 32 by 32 pixel image of like a cat, right? And then you look at the size of the file and it's like 4 gigabytes. Something's off about that, right? Like, definitely, there's probably something more there. Since generally statistics are relevant information about the actual data, if you can take enough metadata, this is how a lot of companies are able to build a profile on you. They don't necessarily take your data, they take so much metadata that they're able to build an information about you. For example, say you use evil signal, and evil signal is like, we're going to share your data with everyone. Or we're going to collect your data versus real signal, which doesn't collect your data. Signal knows that you sent a message at one place, at another place, and at another place. It sends that information off to anyone who buys that data, which is Venmo. And Venmo sees that you Venmoed someone named Coffee Shop $10. And you also sent a signal text for $10, or geez, you sent a signal text for like to someone, and then another person got coffee for $10, and then you kept messaging each other. You can kind of figure out that like a conversation happened there without knowing what the data was, and then like say they go off and buy like, I don't know, gasoline or something. Maybe that conversation was about committing arson, right? So it's, you know, that's a crazy example, but the whole point there is like, if you have enough metadata, you can kind of figure out what's going on. But also you can just hide things in metadata. So there's a few metadata tools. One of them kind of just comes standard in a lot of Linux systems. It's inode. You can look at the actual underlying file information about a file. So files are represented as these things called inodes. And that's like the lower level version of like a file which specifies like where it is in memory, where it is in memory, like how to access it, and then what's referencing it, and like when it was created, when it was modified. Really interesting thing about inodes is that you can make in Linux, there's two kinds of things called links. There are soft links or a symlink and a hard link. A hard link is really interesting because if you make a hard link to a file, you can delete the original version of the file using RM, and that file will still exist. Like the exact same file will still exist because there's another hard link to that file. You have to remove all the hard links to a file to get it to go away. And then symlinks are kind of just like shortcuts, where it's like, hey, this is where that thing is. Go there if you want to open it. And then EXIF tool will just look at all the metadata. And then there's a bunch of image metadata tools as well. There's some information about EXIF tool. It's pretty nice. Okay, Stego. Who is doing Stego? Have fun.
Yeah, thanks.
Okay, so steganography, or I'll probably just call it Stego from here on out, is that the concept is to hide a message in some other data such that I can smuggle it across to my friend. And if people see it, all they observe is like a normal picture. But my friend and I have some secret process where we can extract data which I've hidden in there, right? So I can smuggle some messages to my friend. It's an inherently a guessing process. So I'm going to describe probably the most famous technique to smuggle that data in an image. But if you ever see in a CTF competition where they're like, here's an image, extract the text, you're just going to have to like go at it and just guess a ton of different techniques and approaches. It's a lot of people dislike it, but a lot of beginner CTFs tend to love this kind of thing. Yeah, so there are ways that you can do some statistical approaches, but a lot of times it just reduces to guesswork. So I'm going to describe quickly the most popular Stego ideas on images, and it's called the LSB encoding. So it stands for the least significant bit. Really, this isn't useful in the real world, but you should know this just for the sake of solving CTF challenges in case they're asking you. The concept is like this. An image is made up of pixels, and each pixel has a red, green, and blue value. And these values range from 0 to 255 because it's a byte. So each pixel has 3, what's considered RGB picture. So every pixel has 3 bytes of RGB values. And so the premise is that, I got a visualization here. The premise is that for every pixel, I'm going to extract the RGB bytes. And I'm going to say, look at the last bit in that byte, and I'm going to concatenate them all together to form a new message. And so what that means is, the reason we like that is because modifying the last bit of the red value changes it by at most 1 value, right, out of the 255 values. It either increments it or leaves it the same, right? And so result of that is that despite having encoded arbitrary amount of bits, assuming your file size is large enough, into this image, it visually doesn't change the image much. Like it makes the red channel like a tint darker by 1 value, for this pixel, and the blue value this much darker. You really can't tell the difference visually, but when you inspect it, you can extract it. And somebody to a person looking at that image and its data as it gets sent from me to my friend who I'm trying to hide this message to, they have no idea. It's going to be hard for them to know. Maybe they have some statistics, probably not, right? And so formally, what you can do, if you can take the red byte, so you can take most pixel to 3 bytes, red, green, blue. Take the last bit, you get that by using a bitmap and concatenating those bits. So really though, there's going to be online tools for you to use for this. So just go ahead and Google like LSB tool online. You'll find great resources that you can just copy and paste the image online, and that's kind of how we solve this challenge. And it's just guesswork which bits they use. Did they only change the red byte? Did they change the red, green, and blue bytes? It's going to be guesswork from there on out. So let's hit the next slide. Here's what I wanted to talk to you about. Is can you really tell the difference between these? So on the left is the original image, and on the right is an image where I've encoded for every pixel, like I've encoded like a huge message into it. And if you were to apply the process which I just described, you'll extract that huge data. It could be a text message, it could be another image if I wanted to be, but visually you can't tell the difference between these images. Okay, I think that's all for this. Any questions on that? So that's kind of went quick through that. Excellent. All right.
Is that all that we had for memory forensics? All right, I'll add a little bit more. So the next thing we're going to cover is memory forensics. And memory forensics is basically looking at actual dumps of memory to find valuable information. So that could be something like, oh, I took an image of a whole RAM, and I am going to here's the image of the whole RAM. Find out what was happening at this time. Or like a CPU, or sometimes they do here's a whole file system, figure out what's going on. And the interesting thing that you can do with that is using a tool like Foremost. So someone gives you a whole file system that you can use. There's data recovery tools. So basically you can recover deleted files from a mount. And a mount is basically just what happens when you take a bunch of memory of a system and you say, hey, treat this as a drive or a partition on my computer. So you can use hidden files inside a drive. Another thing that you can use is binwalk, which is a tool that may be relevant today. So another thing, network forensics is the next one. Do you want to cover? I'll do it. So network forensics is kind of like the act of looking at packet captures and network traffic. It's a great way to get a good understanding of what happened in the network. The way to do that, why did that not work? Is Wireshark. So this uses network packet analysis. Basically, here is what the main tab of Wireshark looks like. It's got really good filtering features, so you can just filter by category and then value. Then we're going to do probably a whole meeting on this either later this semester or next semester if you're interested. And you can follow conversations and view individual packet values as well. So if there's a TCP conversation that's going on, you can follow that from the initial synchronization to the final message. And again, we'll do a meeting on this later, but for these meetings, it shouldn't be too much to worry about. Okay, and then lastly, systems and organization-based forensics. It's really hard to do. Forensics is really hard to do at scale, especially if there's a very large script-based attack that is able to attack thousands of hosts, and you have no idea which one actually did a bad thing. So enter organization tools, a lot of which are really expensive and you probably won't ever have to touch until you're like in the real world. So examples are SIGPwny, Kibana, Velociraptor, Akira, I can't remember what it was called, but it was like Wireshark but online and shitty. So they exist for a reason. They exist because some people need quick access to like enterprise grade like tools that can look at not just one host, but like what thousands of hosts are doing. And many of them cost a lot of money, but it's really good to know that they exist. Hopefully TracerFire is coming soon to U of I, and if you're interested in learning more about like enterprise grade forensics tools, you can do that there. Another thing that I forgot to kind of touch on here is the systems version, the systems part of like forensics. There's generally two types. There's dead analysis and live analysis. So like someone brings in a computer. Dead analysis would be, we've turned the computer off and we've cloned the hard drive. Here's the hard drive. Like do what you want on it. If you mess it up, like here's another copy. Live analysis is a little bit more risky and it's not as common, but it's getting more common. That basically is, okay, here is the live computer, like do analysis on it. That's actually pretty, you gotta be careful there with the law because sometimes like, you know, changing a file can be considered tampering of evidence. So, you know, just be super duper careful with it. I've talked to my law and policy professor and he says like, to get around the whole tampering with evidence thing, they take photos of literally everything they do on live devices. So it's really interesting. So yeah, there's a bunch of MISC forensics tools for what that may be relevant. I'll upload these slides to Club General. Cool. So that's the meeting. Our next meetings, the weekend seminar is going to be the spooky SIGPwny summary. So it's who SIGPwny is, what SIGPwny is, basically what we do all in all, and also this semester, and what our plans are as like we can be more in person. So like what are like next year, are we going to go to conferences? Are we going to do that sort of stuff? And then Thursday is either going to be the end game within security, so like the jobs meeting. How do you get a job within security? What end game opportunities exist? We're going to we covered that a little bit in the very first meeting that we did, but we're going to have like a whole meeting on that. If you are more interested, I'm going to send out a like an add everyone poll. If enough people are interested, we may move this to the Sunday meeting and then run OSINT next Thursday, which is like forensics but on people. So that's like my favorite meeting to run, and it might be a little tight in terms of time, but I could probably make something really cool for this meeting. So yeah, whatever you want to do. Otherwise, I'm gonna go to the next slide. Does anyone have any questions at all about any of the things we covered today? Yeah.
I have a general question. So if we want to practice like forensics or any of like the cybersecurity thing, it's like $500 server that we don't know what it is, and then we like breathe into it, do we get in trouble?
Yeah, that's a fact. So
But like if we're trying to learn.
is it like a, so, okay, so you got, if you want all the extended talk on that, watch the law and policy, the law and ethics for sure. What I'll tell you in 15 seconds is it's probably a felony. Intent means a little bit. So like if you were like, oh, I'm trying to learn, or oh, I'm trying to be good, it means a little bit, but it doesn't mean so much to the extent that you're not going to get in trouble. If you want to learn this stuff, look for CTFs, look for places that are designed for you to go into them and mess with them and screw with them and like learn this stuff. It may be idealized and like kind of the romanticized version of actual security. That's like one big thing that I've learned about like, so I do corporate red teaming and pen testing for like banks and hospitals and stuff like that. And one huge thing that I've learned is CTF and that stuff is very idealized and very romanticized. In the real world, a lot of the vulnerabilities that we find are very repeatable and very common. Like I wrote an extension for a tool that I made called LDAP, which is an LDAP domain dump analyzer. It's a parser basically, and it will I wrote a function that says this summer where it just analyzes every single attribute in Active Directory and looks for a password, like passwords. It just looks for passwords in Active Directory in plain text. And that shouldn't work, right? Like you shouldn't put a plain text password in Active Directory, which is basically like, it's basically how our net IDs work. So it uses something called Active Directory where it's like, it looks like it's a big directory of people. And you really shouldn't keep passwords in there. You just shouldn't keep passwords in there. It worked 4 times this summer. Like I found plain text passwords 4 times this summer, like at 4 different clients. So like CTF is good and it teaches you really valuable skills. In reality, it's a combination of like CTF skills and like general security knowledge and like, okay, what is something that someone should be doing? Okay, don't put passwords in Active Directory in plain text. Oh, they're not doing that. Okay, I have access to an account. Okay, default credentials is a really big one. Like just like if you set up a system and then forget to revoke default credentials, someone will just like Google what are the default credentials for like an Aruba network switch, and then from the network switch like create a tunnel for themselves into the network. Or like I've seen some really bad ones. Some stuff that I can't talk about because it's like ongoing. The default credentials are a problem. So yeah, that was more than you asked. That was more information than you asked for. But ask for permission in like the worst case situation. Just ask us. Like ask me, ask Nate, ask Chris. We've done a lot of this stuff before. We know what's good and what's not. So, any other questions about forensics or just I guess general stuff? Otherwise, I'm gonna end the meeting.
I thought so.
Wow. Okay. I'm gonna stop the recording. Have a great night. Wow, that was rude, Siri.